All right, good morning.
Morning. Morning. Morning.
Morning.
Morning.
Any questions? Got a number of Git-related questions in email and office hours. Yeah, go for it.
So I was working on homework 2 last night,
Mm-hmm.
and I realized I was doing things out of order,
Okay.
and I accidentally made the project in the SSH directory.
Okay.
Is that an issue?
Yeah, that's probably not a good idea because the files in the SSH directory are pretty important. And if you accidentally clobbered them, you might suddenly find you need to redo a bunch of stuff, and so on. So I would go ahead and just from your home directory, right? Like, just CD to get to your home directory,
Yeah.
and then make your new directory, and go into there. And then if you want to copy files if you already made some files and put them in your SSH directory, you can do, something like copy tilde slash dot SSH slash, whatever into your current directory. Or, just copy and paste the contents or type them in again or something like that. We haven't written too much that's really large at this point, so but yeah, definitely leave your .ssh directory kind of intact with just the ID pub and ID or IDRSA and IDRSA.pub.
Okay, thank you.
Mm-hmm. And for those of you who don't have a lot of experience with Linux, maybe you took 121 somewhere else, or maybe you took 121 a long time ago, and so on and so forth, right? The whole purpose of this course is to get better at Linux. There's that how-to guide which gives some initial commands, but if those aren't helpful to you because you're missing, some of the foundational stuff before that, right? Definitely let me know. Come by office hours and let's go through some basics. Being able to log into the server or, start a Linux terminal session if you're running Linux on your laptop. Fundamental ideas like the fact that Linux is case sensitive, right? And if I make a directory called uppercase CSE224 and then I try to change to lowercase CSE224, it's a different creature, right? This idea of making directories, changing to directories, copying files. So if you haven't done those, you're rusty on those, right? Come by and let's just go through some of this stuff while you're screen sharing. And once you get, a few of these commands down and you start moving around your file system and stuff, then it starts to get easier, right? It's one of these things where the more you learn, the easier it is to do other things and to learn more things. But that first kind of kernel of knowledge can be tricky sometimes to get started with. Yeah, so if you've used DOS, for example, then you've got some experience with the command line. If everything you've done on a computer is through, something like Windows where you're doing point and click, the whole idea of the command line can be kind of unfamiliar, right? This idea of here's a window and I'm going to type something in here and something's going to happen, right? Well, if I want to see my files in a folder, I just click on the folder and there's, a picture of all my files. From a command line, right, I use this command ls and it shows me the name of my files. With a folder, I can go to view and I can say, show me detailed properties. From the command line, I can say ls-l and see details like how big are my files and so on and so forth. So it's...
Like a tree?
Sorry, say again?
I can't remember, but is there a command for like tree? You can see all the files in like a tree layout?
I don't know if I've installed that, but yeah, there should be.
I think that might be a command prompt thing.
Oh, right.
Yeah. So if I want to see a whole collection of files, I usually just say find space period, and I don't want to do that here because it'll show you all kinds of usernames and stuff, but this command find space period will show you every file from your current directory on down. And it's not a nice, tree-like presentation of it, but it will show you all of the information in there. Or, you can just keep moving down directories and looking and so on and so forth. So if you start from like /, which is the top level of everything, right, you can see the files and directories at the top level of this, this file structure. And if you do an ls-l, anything that has a D in the beginning, that's a directory. And anything without a D is a file or a link to another file. So pretty much everything under / is a directory. But if I go into, say, etc, and I do an ls, I see 4 directories and 1 file. And if I were to go into the x11 directory, I see a bunch of directories and a handful of files. And if I were to go into, I don't know, app defaults, there's a bunch of files in there and a couple of directories. Nope, no directories, just files.
I have a question.
Yeah.
For the homeworks and such, we have to, make a folder and then push it to the Git repository.
Mm-hmm.
They're always all in capitals, which drives me nuts. Is it fine if I have them in lowercase, or do you have like some robot checking them?
I would make them uppercase if it says uppercase.
Oh, okay.
If it really drives you bonkers, what you can do is you can make a different directory which is lowercase and make that a link to the uppercase one. But yeah, I'm going to, for example, on Friday morning at 8, I'll just run a command which will try to pull down the Git repositories for everybody in this class and the other class, using the GitLab ID that you sent me an email, but using the name uppercase CSE224. And if it doesn't find your project right, I might go in this time and manually look to see if there's a lowercase or things like that. But in general, these automated things, you definitely want to stick to the uppercase. And yeah, it is kind of weird to be uppercase, but it can help in the sense of, most of the files that we write, the .c files, .h files, make files are usually lowercase. And so directories I tend to make uppercase. README is just kind of traditionally uppercase, just because it makes it stand out when people look at your directory listing.
I have another question.
Yeah.
How does the assess work for that bash script for 402?
So we're going to talk about that in a few minutes, but basically you're just going to say, if you make a bash script and you call it ODP 402, your assess command would be assess ODP 402, and then just again ODP 402. Because we don't compile bash scripts, so this is the executable, but it's also the source code. So you just type it in twice. All right, go ahead and send me an attendance note. Let me know that you're here, and let's start talking about details of bash, which is what you're going to need to use to do ODP 402. And on the attendance, make sure that it's your name, a dash, and then the word here in uppercase. I'm getting some things with colons or with a space instead of a dash and so on. So make sure the dash is there, and the word here, and your name in that order. All right, so what is bash? Bash is a program. It's written in C. And what bash does is it says, hey, hang out here and wait for the person to type something. And when they type something, see what they typed and do something in response. And if there's output generated in response, show the user that output by displaying it in this window. And then go back to, print a prompt and wait for them to type something else. So if I say PWD, what's happening? I'm typing in 3 characters. When I hit enter, this C program, which is called bash, reads that and says, oh, PWD, they want to know what directory they're in. and it looks in its, memory of variables where it records what directory I'm in, and it says, oh, you're in /home/Nick. And we're done with that command, and it goes back and prints out a prompt. And if I say ls, it will, run a command that looks in my directory, sees what files are there, prints them out, comes back and prints out a prompt, waits for another command. And this is just a program. It's a program stored under /bin. And it's just called bash. It's an executable program. And somewhere there's a bash.c, presumably, which is, the C code that makes this up. It's actually a bunch of files. But it gets compiled and built, and it creates this executable. And it's just a program. I can, make a copy of that executable in my own directory and have a file called haha. And if I say haha, guess what? I'm running a new bash session. Right, my prompt number reset to 4999, and I can do whatever I want. And if I exit from here, I'm back to, where I was before I said haha, which was, running a bash shell. And if I say PS, which says show me the processes that are running on the system right now, you can see there's two processes. One of them is called bash. That's this program that's running right now. And the other one is PS, that's the command that I just typed, PS, which says show me my processes. Alright, so what we're going to do in the first part of this course is we're going to learn a bunch of commands we can use in bash, and then we're going to use those commands to create short scripts that will do presumably useful things for us. So let's look at some basic bash commands. And so probably the simplest command in bash is echo. And so what is an echo? You go in a cave and you say hello and it says back to you hello, right? Well, that's what the echo command does. So if I say echo hello without a typo, it says hello. That's all that the command does. If I say echo this is fun, it says this is fun. Okay, pretty simple command, but a really useful command. This is kind of like what printf does in C. Right? When you want to print something in C, like hello world, you say printf, quote, hello world. So I can say echo, quote, hello world, and it says hello world. Now I can do this with quotes or I can do it without quotes, and we'll see the difference for that in a bit. But in general, we'd usually want to put things in quotation marks. But with echo, you can actually get away with just saying, echo hello world. And it'll work the same. All right, well that's fun for about, 30 seconds. We can make bash, say things to us. But we want to do something more along the lines of what we do in C. So really quickly, we want to have variables. All right, so I can make a variable like x, and I can say let's set x equal to 10. Now if I echo x, what's it going to say? It's going to say x, because that's what echo does. It repeats back whatever you ask it to echo. So I said x equals 10. I said echo x. How did I get an x instead of a 10? And more importantly, how do I force it to give me that 10? How'd you get a little cool icon next to your name? That's pretty neat. I'll have to play with that. All right, so variables. So x is a variable, it's equal to 10, but if I just say echo x, it's going to show me an x. So if I want the value of the variable x, put a $sign in front of it. Echo $x, that shows me a 10. And if I say echo, quote, x equals $x, this will show me x equals, because that's part of what I asked it to echo. But then for $x, it replaced $x with the value of x, which was 10.
So it's an F string, basically.
Yeah, yeah. If I say x equals 20 and then I echo x equals $x, now it says x equals 20. If I say x equals hello, now it says x equals hello. And this is permanent until I exit. If I come back into Linux and I echo x, it says x equals, and there is no value. So the $sign is telling Bash, I don't want you to echo the symbol x. I want you to echo the value of the variable x. If I haven't given x a value, then the value of $x is just nothing. But if I say x equals, this is fun, ha ha ha, then $x means this is fun, ha ha, with an exclamation mark. So we can create variables, we can assign them values, and then we can read their values back by using $x. And if I were to echo $x, 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 it says this is fun, ha ha, 5 times. So I can say what is going on with a bunch of $x's in between, and what's it going to do? It's going to replace each $x with this is fun, haha. Okay, very, very kind of mechanical procedure, not a whole lot of wiggle room around what's happening here. So if I set x equal to 10 and I echo $x, I get a 10. Suppose I echo $x times 2. Let me put this in quotes. So x is equal to 10, $x is equal to 10. Echo $x times 2, what is it going to give me? It's going to give me 10*2. Why? Because $x got replaced with 10, 10, and then it echoed an asterisk and it echoed a 2. So this is what I mean by very mechanical, right? To us, if we set x equal to 10 and we do something like x asterisk 2, we expect to see 20. But Bash is not going to make that assumption. It's just going to literally say, okay, $x, let's replace that with a 1 followed by a 0, and then let's print out an asterisk and let's print out a 1. If I do $x plus 1, it echoes 10 plus 1. So that's the first thing to keep in mind. These things are completely literal. And yeah, so good question. If I just echo x, it says x. So the $sign says replace $x with the value of that variable.
I meant, sorry, I meant x without quotes, though.
Oh, same thing. So, but I'm gonna try to stay in the habit of always using quotation marks when I want to echo something, just because we can get into trouble with some commands if we have something with spaces in between. Echo handles it well, but some other things won't. So I'm pretty much always going to use double quotes when I say echo something. But they don't actually change the behavior of is this an x or is it the thing that x is equal to. But there is one thing we can do if we echo single quote $x. The single quotes stop the $sign from being treated as something special. This just says $x. So mostly we're going to stick with double quotes. So variables are pretty mechanical in how they work. All right, so suppose we want to actually do arithmetic on a variable, right? I have this I have this variable x which is equal to 10. Suppose I want to actually multiply this by 2, right? So there's a syntax we can use, and it looks like this. We say $paren, and then we can put an arithmetic expression inside here, and it will replace variables with their values. If we use an asterisk, it will do multiplication. If we use a plus sign, it'll do addition, and so on and so forth. So if I say echo $paren x times 2, and then we end with 2 closing parens, that'll give me my 20. And if I say echo $paren x plus 1, that'll give me 11. Or 1 plus x. Or 1 plus 2 times x will give me 21. So we can do arithmetic like we do in C, and the syntax is $paren, and then some expression, and then 2 closing parens. Now there's multiple ways we can do this, and if you start looking online, you'll see lots of different versions of how to do this. You can use back quotes, you can use some function calls and square brackets and so on. This is the only way you're allowed to do this in this class. Okay, if you want to do arithmetic, it's got to be $paren, your expression, and then 2 closing parens. All right, and it's very, very simple to use, but you got to get it just right. This is also a good point to mention that spaces really matter in Bash.
Hey, if you wanted to put other things in that string with the paren and then the equation, you could have other letters in there too, right?
Yeah, so I could say y equals 11. And I could echo x plus y. Let me try to stick to putting quotes. Right, and so that's 21. And I could make this, look like an equation. I could say $x plus $y equals, and then $paren x plus y. And now I get a nice little equation out which says 10 plus 11 equals 21. And if I set x equal to 45, this will tell me 45 plus 11 is equal to 56.
And then after the parens, you can just write any characters, right? Like if you wanted to say it's 56 apples, that's what you're adding.
Mm-hmm.
Okay.
All right, so spaces are critical. All right, and we'll see that. I can try to break it now, and sometimes it'll break, sometimes it won't. But when I'm doing an expression like this, don't put in extra spaces. Right? Okay, we'll see if we can break it. I don't think this will break it. This will still work pretty well. But for example, if I do $ space x, it shows me $ space x. Right? So text that you're writing that you just want to have appear literally, the way that you type it, you can do whatever you want with spaces. But inside these expressions that have $ in them, be really careful of your spacing. And generally don't add extra spaces unless we're saying that they're required. All right. So that's variables. That's how we can do arithmetic. We've almost got enough to do ODP 402. But we need to talk about scripts. So what is a script? It's like a movie script. It's a set of directions describing things that should happen. So a bash script is a script of instructions for what bash is supposed to do. And bash, by the way, is an example of what we call a shell. So a shell is a program like bash that basically takes commands from a user, performs action, shows you output, waits for another command, roughly speaking. So it's not the same thing as Linux. It's a program that runs underneath Linux. right? And in this case, I'm running a program called bash, and that is a shell. We can look at the manual page for bash, and it'll tell us this is the born again shell, right? So there are a number of different shells. There's the corn shell, KSH. There's the C shell, CSH. There was the born shell, which was just called SH. That was sort of the first major shell. So bash is the born again shell. It's a play on extending the born shell SH to have newer and better features. Hello. And this is another manual page. It's really, really long because it's a very complex program. And all the gory details you might want to know about the born shell you can find in the manual page. But it's yeah, it's Jason Bourne.
Is it Jason Bourne?
Yeah. It's not actually.
English class of Jason Bourne.
Bash came first. But maybe that's why they named him that. Alright, so we're playing with bash, and there's a lot of information in the textbook on bash and all of these different concepts. So a bash script or a shell script is a collection of commands that basically say bash should do something. Alright, so what are some commands we can play with? We can say date, and it'll show us the current date. We can say pwd, and it'll show me what directory in. We can say df, and it'll show us how much disk space is available on the system, which is, 38 gig. It's not a big drive. So we can use all these commands. So we could make a bash script that will execute some commands for us. So let's go into, do I have a work area? Let's go into CSE224. And I'm going to call this script 1. And I'm going to say echo the date is. And then I'm going to echo the date command. And then I'm going to say have a nice day. Alright, now if I were to type these 3 commands from my command line, I would expect to see the date is, and then I would expect to see the results of running the date command, and I expect to see the words have a nice day. Alright, but instead I've put this in a file called script1. So cat is a way to look at the contents of a file. So I can say cat script1, I can see there's 3 lines in there. Alright, if I want to execute this, all I have to say is script1, but by default, we're not allowed to execute arbitrary files. Because if I thought I was executing a shell script, but this was actually a text file containing, the contents of War and Peace, my bash script would suddenly be trying to execute, thousands of commands that made no sense, and they might do bad things. So by default, if we write a bunch of commands in a file, we can't execute that file. And we can tell that by doing an ls-l. Now my shell is set up to give very restrictive permissions. So this file, script1, I can read it, and I can write it, but I'm not allowed to execute it. And nobody else is allowed to do anything with it. Nobody can read it, nobody can write it. Alright, so, yeah, this is all leading up to ODP 402. So we have to make this program executable, and the command for doing that is chmod, change mode. And the most common command we'll use is change mode 755 script 1, or whatever file it is that you want to execute. So if I say change mode 755, and now I do an ls-l, we see some different information over here. These are the permissions on the file. And the first 3 letters say what I'm allowed to do to the file. I'm allowed to read it, I'm allowed to write it, and I'm allowed to execute it. That's what the X says. I also set it up so that anybody on the system can read and execute this file, but not write it. So this second set of characters says anybody in my group is faculty, so Izad, Scott, whoever had faculty accounts on the machine, could read and execute this file, but not write it. And this last set of letters is what everybody else in the world can do. So if it's not me and it's not someone who's faculty, you can read the file, you can't write it, but you can execute it. All right, the important. Go ahead.
Plus X.
Say again.
Instead of doing 755, you can just do plus X for execute.
That's true. Yeah. So the critical part is this X, which says execute permission. And this means that I have permission to execute script 1. So if I say script 1 now, it should go ahead and perform the actions given by each line of that file. And so it says the date is, and then it prints out the date, and then it says have a nice day. So there's our first shell script. It's a 3-line program, and it just executes a bunch of commands.
Does it say 755 because the number 7 refers to giving yourself reading, writing, executing privileges? The 5 refers to your group giving reading and executing privileges, and the other 5 refers to then public reading and executable privileges.
Yep. So let's say that again, although you just said it very well. But let's spell this out. So there are 9 permission bits that we're interested in with a file. These bits describe what the owner can do. These bits describe what people in your group can do. And these bits describe what everybody else in the world can do. And this is read, this is write, and this is execute. And same here and same here. So when we want to use change mode, we use a 1 or a 0 to say, is that permission given or not given? So 1 means we're granting that permission, 0 means we're not granting that permission. So if the owner has read, write, execute, we write 1, 1, 1. If the group has read, execute, but not write, that's 1, 0, 1, and so on. And now if you turn each of these into a decimal digit, right, think of them as octal, that's the argument that you give to the change mode command. So if I wanted to have everybody be able to read the file but not execute it, and I also wanted to be able to read it but not execute, I would say I want to read and write but not execute. I want groups to be able to read but not write or execute, and world to be able to read but not write or execute. That would be a 644. So if I change mode to 644, I should see read, write, read, and read. Right, so there's read, write, read, and read. So that's where those magic numbers come from. Yeah, it is pretty cool, isn't it? All right, so we've got question.
No, I said white.
Yeah, cool. All right, so we've got scripts. We can write series of commands, right? But we usually want to be interactive in our programs. If our programs don't take input, then they'll generally do exactly the same thing every time that they execute. Now, sometimes that's good. You could make a script which says git add star, git commit -m blah, git push origin master. And any time that you run that script, it would do all 3 of those git commands for you. And that could be useful. But a lot of times we want our git scripts to be able to, our bash scripts to be able to read input from the user and do something accordingly. So our next command is read. And read is a way to get input from the user.
Nick,
Yeah.
before we go any further, I just want to I want to ask something to make something clear.
Yeah.
Is bash automatically enabled if you call a file script and then something after that, or is
The file name is completely irrelevant. You can call it pretty much anything you want within reason. Don't call it something like test or PWD or something like that. There's all kinds of reserved words. But for our ODPs, I would generally call it ODP 402, ODP 403, etc. But if it's executable, and since I'm running bash already, if I type the name of a file, it will run it under bash.
So bash is automatically running even if you write in a file, even if you write a file and program even in C.
Yeah, but let's go ahead and talk about this anyway. I was going to do this later, but let's talk about shebangs. So in general, if I'm writing a file and I want it to be run by bash, I put a special line in the beginning. I say !! /bin/bash. All right, so # is how we make a comment. Any line in my script that begins with a # is ignored when I try to run my script. But if the very first line of my file is a ! Followed by the description of a program, then that's the program that will be used to execute the contents of this file. So if we're writing bash scripts, which is most of what we're going to do, always make the first line ! /bin/bash. Now if you're running bash already and you type the name of your file, it's going to use bash. But if somebody was running a different shell, like the corn shell, and they type the name of your file, it would try to execute these things using the corn shell. So you put this first line in here in the very beginning, and that'll force it to use the bash program. Kind of similar to when we include standard.io.h in the sense that it needs to be in your file, but in a bash script it has to be the first line. If I put something before here, if I put an empty line before here, then this is nothing more than a comment, and it doesn't work as a shebang. So make that the first line, then you're guaranteed bash is going to be what executes your statements.
I have a question.
Yeah.
I made an alias yesterday for adding, committing, pushing, and it's gone now.
Right, so aliases only persist as long as you're logged in. But remember we talked about the .bashrc file? So in your home directory there's a file called .bashrc. And if you had typed that alias command in here, then it would get executed every time that you log in. So bashrc is basically a bash script, but it's executed automatically whenever you start a new bash session, such as when you log in. So put your alias in there, and then it'll basically redo your alias command every time you start bash. So that makes it persistent. Yeah, you're welcome. All right, so the read command, and we can do this from just our shell here. So echo x. Okay, so x doesn't have, or x is just x. Echo $x. So x is equal to 45. Okay, I can say read space x. And instead of coming back to a prompt, bash is sitting here waiting for me to type something in. So I can type a 99 and hit enter, and now if I echo $x, it's equal to 99. If I say read x and I say haha that's funny, and then I echo $x, it's equal to haha that's funny. So this is the way we can get input from the user. Hey, all questions are good in here. Don't worry about it. Yeah, if things go off topic, I'll pull them back in. But this is such a huge topic. Pretty much anything that people are asking is going to be helpful. So let's go back in here and let me do the following. Let me say echo. What is your name? And then I'm going to say read, and I'm going to read into a variable called name. And now I'm going to say echo hello $name. And at the end here, when I say have a nice day, I'll say have a nice day $name. And let me change the name of script 1 to I'll just change it to GM for good morning. All right. So I'll say good morning, and it says, what is your name? And I'll say my name is Nick. And it will say, hello, Nick. The date is such and such. Have a nice day, Nick. Right? So this is simple, but really, really key. Right? We're getting input from the user, and then we can get a hold of that input by saying $, whatever variable we read that input into. If I had said read X, then X would have, you know, the name that the person typed. And it doesn't care what you're doing here, right? What's your name? I can say that's my name, and it'll say hello, you know, all of that, and have a nice day, all of this. Except I typed some funny characters somewhere, so this got truncated. Yeah.
If you if you have like a bash read command and then you like record and stuff, can you save it to a C variable and then you use that, try and use that C variable in a call to a function, or something like that? Will that mess up the bash script or no?
Well, we haven't really talked about functions yet from Bash, and so there's no direct way right now to be able to call something like a C function with this. We will be able to do that eventually, and it really just kind of does whatever you tell it to do. So if I tried to call a C function that expected a number and I passed it my name instead, right, something will happen. One of the nice / horrifying things about C is it does exactly what you tell it to do. And that can, you know, make your life really easy, or it can make it very interesting. When we get to Java in 2.23, Java works really hard to kind of protect you from yourself, right? And when you get to other languages, they do this even more so. But C is really pretty close to assembly language. So if you've done Engineering 270, you know, on a PIC processor, just about anything that you write will execute, right? As long as there's not a syntax error, it'll do what you tell it to do. C is very much the same way. Bash, a little bit more high level, but still pretty much kind of does whatever you say. All right, so, and yeah, someone noted in text, in chat, that Bash also has a printf. And it works very much like printf in C. You can format things and so on and so forth. We don't need to do that yet, though. We'll be able to get away with just plain old echo. So let me change my good morning program and say, you know, how old are you? And let me read my age. And then let me say, next year you will be age $, age +1.
Is there a way to only accept integers?
Not very easily. I talk about it a little in that Bash guide on Canvas, but for now we're going to assume that people are well behaved, and if I'm asking for their age, they're going to type in a number. But we'll see ways to know if that happened or not later. All right, so let's say good morning. I made a typo somewhere. So how old are you? Quotation marks. So good morning. How old are you? I am 25. And it says next year your age will be age 26. Pretty straightforward, right? And this is more than you need to do ODP 402. So 402 posted, and if you look at /temp/readme 402, it'll show you the instructions for that ODP. And it basically says, write a bash script that reads one line of input from the user, treats it as an integer, prints out 2 times that integer. So if you call your script ODP 402, then if you type in a value of 12, it should print out a value of 24. And that's the only thing it should do. So let me show you what this should look like. So I think I called my program good program instead of ODP402. So type in the name of your script, hit enter. It can't print anything. If it prints out, enter a number, you'll get 0 out of 10. So don't print anything. Just sit here silently and wait for a number. It's bad practice in general, right? You'd want to prompt the user. But for the ODP, don't prompt. Just wait for a number. Person types in a number, 45. It just prints out twice that number and exits. Person types in a negative number, it prints twice that number and exits. Yeah, go ahead.
I did a prompt and I got a 10 out of 10, but it printed the 10 out of 10 grade 3 times.
Yeah, there's 3 different tests that run. I'm guessing you did a prompt with a -p.
Yeah, I did a dash.
Yeah, so that'll let you get away with it, but if you echoed something, then it would have given you 0.
Okay, yeah, the dash P is pretty cool.
Yeah. All right, so as someone asked in the beginning, because we don't compile bash scripts, right, you basically say assess ODP402, ODP402. You list it twice. But what the assess command is seeing is this is the program I'm going to run. This is the program with the source code I'm going to look at, right? It's the same file, but you go ahead and you specify it twice. That was the easiest way to set this up. So assess ODP402, ODP402, use the G command, and for this one, there's 3 tests that are run. It basically tests with a positive integer, a negative integer, and 0 to make sure all 3 of those work. So you'll get a 10 out of 10 3 times, and your final score in the system would be 30 out of 30. And then when this gets uploaded to Canvas over the weekend, it would just show up as 100%. If you only pass 2 of the tests and you got a 0 out of 10 on one, then you get a 20 out of 30 and Canvas would show a 67%. So you'll see multiple tests in a lot of these ODPs. Where's the prompt for ODP402? /temp/readme402 on the server. And going forward, all of these prompts will be on the server under the /temp directory. So you could just cat /temp/readme-402. And on Canvas, ODP402 should point you to this directory. You may have to update it if you've had Canvas open for more than a day.
Yeah, it does say to look in that directory.
Okay, cool.
In the assignment description.
Awesome. All right, and then there's also an ODP403, but don't do this one yet. This is for tomorrow. Right, so right now you're doing ODP402, and when you run the assess program, it should say you are about to assess your code for ODP402, read a number, multiply by 2, print it. So if you happen to read ahead and look at the ODP for 403, and you wrote a program to do that, and you try to assess it, don't do it, right, because it's going to be checking to see if your program matches ODP402. And if you try to run your script and it's saying permission denied, make sure you do that change mode instruction. Right? So for us, it's just going to be change mode 755 ODP 402. That makes it executable. That's chmod. All right, so that's your ODP. So what we want to talk about tomorrow is other ways of getting input into a program and some other bash commands. And we'll talk about PA1 tomorrow. And you know just about enough to do PA1. We got to talk about conditionals and looping. And PA1 is going to be a bash script. So that'll be our first really large sort of standalone bash program. Send me a final attendance note. Let me know that you're here. And I will let you out 24 seconds early. How about that? Work on 402. If you run into troubles, come by office hours in the... office hours is too late. All right, if you run into trouble, send me a very, very detailed email. Okay, and let me know what's going on. The more detail, the better. If you say my program doesn't work, I can't really help you with it. But tell me exactly what's going on, what command you typed. You can show me screenshots and so on and so forth. Yeah, question.
A question.
Yeah.
Do you want this assignment in lowercase or in capital, or does it matter?
ODPs, you can call them whatever you want, as long as that's the same command that you type, when you say assess. But I recommend, some version of ODP 402 because there are some commands that won't work. Like if you call it test, it won't work because test is a reserved word.
Hey, should I send you an email if I can't get the authenticity of host GitLab to be established?
Yes. It's probably an issue with your SSH key, but we should probably do that in office hours. Because that's going to take some trial and error in setting things up. So if you can come by office hours in the morning, that would be your best bet.
Okay. Well, can I still do ODP outside of the repository for now?
Yeah, the ODPs don't have to go in the repository. You can put them there if you want, but they can be in just their own directory. That's totally fine. The only things that have to be in the repository are the homework assignments.
So how do we do we just do the assess command on the ODPs then instead of just setting them on the repository?
Yeah, I'm not going to look at them in GitLab even if you upload them, unless we're working and you're asking me about it and it's an easy way to look at it. But yeah, you don't have to put those in the repository. You don't have to put them in Git at all if you don't want to. Just use the assess command.
I have an issue.
Okay.
So how do you access the bash shell?
Control D is the easiest way. Hold down Control and press a D. But you can also usually use the word exit.
Okay. So I also have a question for the whole GitLab thing real quick. It says after I made the SSH keygen, it asked me to enter a file to save the key in. What file should I put in there?
Just hit the enter key. So if you read the how-to guide, it says after you type the SSH keygen command, you're going to hit enter 3 times without typing anything. The first time is an answer to the question, where should I save these files? And you just wanted to save it in the default location. So hit enter once. Then it'll ask you for a passphrase, hit enter again, and it'll ask you to repeat the passphrase, hit enter a 3rd time. And that'll put them in a standard location, which is a .ssh directory.
Okay, thank you.
Mm-hmm.
Alright, thanks for the lesson then.
Alright, you're welcome. See you next time. And question in chat about assess and getting the grades. The grades for assess don't show up until I load them into Canvas, which I tend to do once a week. So sometime on the weekend the grades will show up. But as long as it's said that you got 10 out of 10, you should be good to go. And it records a history of all the assess commands that you use. So if something happens and you got 10 out of 10, and then you reassessed and got a 0, I can always go back and see that you had a 10 out of 10. All right, I'm going to switch to my other class. Have a good one. See you all tomorrow.
Alright, see you later.
Thank you.
All right, take care. Bye.
Thanks.
Bye.